Hello again, class, and welcome to Math Minutes video lesson 29. Get your notebooks out and let's turn to page 51, and we're going to look at how to write linear equations that are parallel to a given line, but that parallel line has to pass through a specific point. I know it sounds a little complicated, but we actually have already done all the little pieces and parts that this requires. We're just putting some things together that we've already learned. So let's take a look at our first example. We've been given a line y equals 5x minus 2, and we want to write an equation that is parallel to this line and passes through this specific point. Okay, so because the new line is to be parallel with the first line, the slope will stay the same, right? Because parallel equations, parallel lines have identical slopes. We only need to find the new value of b in our slope-intercept form. So in our given equation, the slope is 5. And it passes through the point 4, 0. So let's look at we need to do here. Substitute m and the point. So let's write this above again. This should look familiar. We have done this before. Y in this case is 0. The m we've been given is 5. It stays the same because we want a parallel line. X is 4, and let's solve for b. 0 equals 5 times 4, which is 20. Let's subtract 20 from both sides. 0 minus 20 is 20, so we have b. Now we're just going to write a new equation. Write the linear equation using the original slope and the new value that we just found for b. So y equals our original slope of 5, but now instead of passing at -2 on the y-intercept, it's at -20. So in order to do problems like this, keep the slope and simply find the new value for b. Let's do another one since we have time and space. Let's do this. Let's say we have an equation that is y equals let's say 2x minus 3, and we want it to pass through the point, let's see, 2, 4. Now, I have no idea what this is going to turn out. We might have some weird fractions, but I'm okay with that. What do? Well, because we want a parallel line, we don't have to do much except find where this new line, this new parallel line, is going to cross the y-intercept. So, what do we have to do? We're going to substitute this information into y equals mx plus b using our same slope. So y is 4, m is 2, x is 2, and we're just going to simply find our new value of b. So 4 equals 2 times 2 is 4 plus b. Let's minus 4 from both sides. We end up with 0 equals b. Okay, well that's not too bad. Let's not freak out because it's 0, all right? Let's write our equation now. So our parallel equation is going to be y equals 2x plus 0. All right, let's take a moment to graph that and see what that looks like. Let's do this. So our first line was y equals 2x minus 3, and then the line that we created that's parallel to it is y equals 2x plus 0. So let's graph these two and see what we get. Our first line, minus 3, start at the end. 1, 2, 3. What's our slope is 2. Up 2, over 1, And our line looks like that somewhat. All right. Our next line, plus 0. Well, what does that mean? It simply means that it's crossing at the origin. Same slope, up 2, over 1, and we end up looking like that. So you can see roughly, without a very technical graph here, that these lines are indeed parallel, same slope, but this one has just shifted up. So don't let that 0, freak you out. So again, that was short and to the point. Bring your notebooks to class, and I will see you there.